what I can see, Dan.
Absolutely fantastic. It looks as if the solar arrays have completely deployed. Absolutely beautiful. We see the surface in the background, something that looks small, rocks possibly, agglomerations of soil. It's just beautiful. Crystal clear pictures.
Now, we weren't sure that we would get a landscape image.
No, and it seems that just a couple minutes ago we saw a good horizon picture go by with the sky as well as the surface in the view. These images are telling us that we've got a healthy configuration for the spacecraft, and we're looking at a surface of Mars we've never seen before. This is a part of the planet that we've only seen from orbit. Now we're up close.
There's the horizon shot.
Yeah, look at that. This confirms what we saw from orbit. We don't see a lot of rocks. We see what looks like surface that might have been modulated, configured in part because of ice action beneath the surface. That's what it looked like from orbit.
And it looks like the spacecraft is on a flat surface. It doesn't
appear to be really flat. From the data we got in the engineering stream, it looked as if the spacecraft is barely tilted, maybe only a quarter of a degree off vertical, and the surface around it looks extremely flat. Looks like a good place to start digging.
Now, some key items we saw earlier, the biobarrier.
Yeah, we'll have to come back and see exactly what that is. Here we have a footpad, clearly nicely planted on the surface. That footpad position is very nice. It looks like the surface is very, very solid. We haven't sunk into the surface very deep at all. But as you were saying, the biobarrier is something we want to make sure has been released so that we can get the arm out. And we'll be doing that in the next while. But the pictures right now are telling us whether it's been released, and I haven't had a chance to look at it very closely yet.
Now, Phoenix is doing all of this autonomously. It was given some sort of marching orders saying, send home information about how you're doing first off.
Absolutely. The way that this worked was that after we went out of sight of the orbiter, out of Odyssey orbiter, then this process of taking the pictures, doing the engineering evaluation, was done autonomously. Now the data is now transmitted up to the Odyssey orbiter and then back to Earth, and we're looking at it now.
So far, it looks perfect. This is all you could have hoped for.
That's absolutely. It's just beautiful, beautiful. It looks as if, from what I can see in the images that are up on our screen, that the biobarrier has deployed, and that we're actually looking at the arm in the configuration that we'd hope to see.
Now, how much data can Phoenix send back? It will be sending a lot of information on how things went during EDL. Will it be sending more pictures tomorrow?
Yes. We're going to begin a process of looking at the landscape surrounding the lander. We're going to be getting a lot more engineering data from the various sensors, the readings of voltages, the internal temperatures, and all of that data will go together. But from a scientist's point of view, it's looking at the landscape right now that's what's going to be interesting over the next several days.
One of the things that Peter Smith talks about a lot is the fact that this could open a whole new era of exploration. That with the rovers we looked and checked things out. This is an opportunity to actually feel and taste and analyze.
Yeah, I like to think of what Phoenix is going to be able to do as sort of a one-armed geologist who's returned from his field trip and has his instruments laid out on the bench and is about to analyze the samples. And so the scooping is going to provide the samples, and the feeding of those samples to the instruments is what we're going to be doing for the next 90 days. It's going to be fantastic. Wow. And the new era, it's quite true. We've got very, very sophisticated instruments on board. We're going to be doing the chemistry, the physical characteristics, microscope observations. Maybe we'll be able to tell something about the history of water at this location over time. We're just all sitting there waiting for us to start scooping. It's, you could say it's really like reaching out and touching Mars. It's a part of a process where, we've been traveling and roving and doing analysis by going up and touching the rocks, but now we're actually picking up the rocks in the soil and bringing them inside our spacecraft, and that's quite new. We haven't done that for 30 years, and we're at a brand new place. This very cold regime is an area on Mars where scientists have been speculating that maybe this is evidence of a new climate regime, a climate regime that was formed on Mars much, much more recently than the rest of the planet. And by much more recently, for geologists, that means maybe the last few million years, maybe the last few 100,000 years. And this is a part of the planet where climate change is happening right now. It happens continuously.
But not only that, you can find out what's happening right now, but also going back in history.
What we think we can do with our scoop and with the instruments is to analyze the material as we dig down. And so just like on Earth, as you dig down, you get information about different ages of materials. We don't know over what time span, and we're not sure that Phoenix is going to tell us very much about the time span, but we will be going back in time as we dig. What we saw from orbit was a surface that had been modified by ice. And that's clearly something that we're going to want to explore here. It's hard to tell. Probably we are not seeing ice in these images exposed at the surface. Our guess is that it'll be down a few centimeters from the material that we see in these images. That's what we'll be first going through. We'll be analyzing the material near the surface and then burrowing down through the hard ice. So in the next few weeks, one of the things that we're most interested in is determining where's the ice. Is it deep? Is it very shallow? Does it have a dusting over the top? In fact, is there ice at the surface, but its color is so similar to the soil that it's not easily seen? That's what's exciting at this point.
Well, there are lots of similarities to what we've seen on Mars with the polygons and then seeing them in Antarctica. So are we looking at the same sort of, permafrost?
Well, we might be looking at ice-modified surface on Mars that we see in the Antarctic regions during the summer. One of the ways that geologists learn about Mars is to study the Earth. And then when we see something on Mars, maybe we've not seen it before, we look for analogs, things that are like it on the surface of Earth. And so that back and forth comparison, now with instruments to analyze the chemistry, is really how advances are made.
Well, these polygons have these sort of trenches, and one of the things that Peter had said once was, boy, it would be great if we landed near one of those trenches and being able to dig into one of them. And
it's going to take some luck, because what those polygons are about the same size as the lander. So you either land close to it and you can reach one, or it's just outside your reach. So we'll be looking at the images to see whether we're close to an edge, one of the departures between the nice smooth region and the lines that define the polygon. That's one of the things that these images are going to tell us, and whether or not we're going to be able to reach out and touch one of the edges of those polygons. I think that what's going on right now is everybody's trying to get a feel for what they're seeing. They're taking these postage stamp size images of both the hardware and the surface,